continuity at a point.
Continuity, we have to find the left hand limit x tends to 0 minus fx, which we will write limit h tends to 0 f of a minus h, that means 0 minus h, which is equal to limit h tends to 0 f of minus h is equal to limit h tends to 0 minus h. H is what? H is a very small positive quantity. So minus h, that means which is not equal to 0. So we have to take this function. So minus mod of h minus h by minus h is equal to limit h tends to 0. Mod of minus h is h, then minus h. If we cancel h and h, then we will get minus 1. So the value will be minus 1 here. We have to find the right hand limit. Limit x tends to 0 positive fx, which indicates right hand limit, which is equal to limit h tends to 0 f of 0 plus h. That means limit h tends to 0 f of h. H is a very small positive quantity. Again I am reminding you, that means not equal to 0. So we have to take this function. So limit h tends to 0 mod of h by h, which is h by h, that is equal to 1. Thus we have seen that limit x tends to 0 negative left hand limit is not equal to the right hand limit. That means the function is discontinuous at x equal to. Next equation, the function fx is given by f of x equal to x sine 1 by x when x is not equal to 0, and it is 0 when x is equal to 0, is continuous at x equal to 0. That means we have to show that the function is a continuous function. For that we have to check the left hand limit is equal to right hand limit is equal to value of the function at 0 or not. So let's start. Limit x tends to 0 minus fx equal to limit h tends to 0 f of 0 minus h, limit that means not equal to 0. So we have to apply this minus h into sine equal to limit h tends to 0. Sine of minus theta is minus sine theta, minus and minus will be plus, so it will be h sine 1 by h. That means limit h tends to 0 into h limit h tends to 0 sine 1 by h. This is equal to limit h tends to 0, h means 0. Again, what is this? As we know, sin x always lies between minus 1 and 1. So it is an oscillating number between 1. That means 0 into this part is equal to 0. Right hand limit x tends to 0 plus fx, limit this part, limit h tends to 0 h, limit 1 by h. So up to this to get the left hand limit is equal to right hand limit. Now let us check whether f of 0 is equal to them or not. Now f of 0 is equal to, as we have seen, x equal to 0 means 0. So f of 0 is equal to 0. Thus we got limit x tends to 0 minus fx is equal to limit x tends to 0 plus fx is equal to f of 0. That means the function fx is continuous at the particular point x equal to 0. Therefore fx is continuous at x equal to 0. Question: discuss the continuity of the function fx at x equal to 1 by 2, and the function is. So the question is to check the continuity. Okay, we will start from left hand limit. Okay, left hand limit, that means x tends to, here the point is half, so we will take half. Left hand limit means negative fx This time we are not going to take h, but by taking the another method, very easy method, or to find the limit of a function. Limit x tends to half, you see as half negative, that means it is less than half, so less than half is this one. Okay, so we have to take this function fx as half minus x. Now put the limit at x equal to half, so half minus half is equal to 0. Then right hand limit x tends to half plus fx, limit x tends to half. This time you can see this function we are going to use half plus, half positive, that means more than half. More than half means what? It is more than half means this one, more than half, x is greater than half, so this function we are going to use 3 by 2 minus x is equal to 3 by 2 minus, you put half, 2 is equal to 1. That means left hand limit and right hand limit are not equal, therefore fx is discontinuous at x equal to half. We no need to go to the third part, that means f of half we are not going to find out, because here only we got our result. Okay. Next question, discuss the continuity of the function fx at x equal to 1, and the function is given like this. Okay, two conditions are given. Here we are going to check the criteria for the continuity. That means left hand limit. You can write here left hand limit like this, LHL. Okay, no problem. LHL means left hand limit. Limit x tends to, the point is 1 minus to represent left hand limit, fx. Okay, limit x tends to 1. Now we have to check 1 minus, that means less than 1. So less than 1 means this function. Here x is less than 1. So we are going to use this function for fx, 5x minus 4. If you put x equal to 1 here, 5 into 1, 5 minus 4 is 1. Then right hand limit, RHL equal to limit x tends to 1 plus fx equal to limit x tends to 1 plus, that means more than 1 is this, so we are going to use this function 4x cube minus 3x equal to 1. Up to this they are okay, so we are going to the third step to find f of 1. F of 1 is, as you see, x is exactly equal to 1, so exactly equal to 1 means x equal to 1 here, so we are going to use this function for this. 5x minus 4, x will put 1 minus 4, which is equal to 1. That means all the three are equal. So we can write LHL, left hand limit equal to right hand limit equal to f of 1. Hence fx is continuous at x equal to 1. Now this is another type of question. You can see we have to find a value of k. Determine the value of k for which the following function is continuous at x equal to 3. And it is given to us that the function is continuous at the point x equal to 3. As it is said that the function is continuous at x equal to 3, so we no need to find out left hand limit and right hand limit separately. Okay, that means both the limits exist. That's why we can write directly that the limit exists. So we can write, since fx is continuous at x equal to 3, therefore limit x tends to 3, fx is equal to f of 3. I am telling about this part, that no need to write left hand limit is equal to right hand limit is equal to f3. You can write only limit x tends to 3 fx. Implies x tends to 3, that means x is not equal to 3, you can see. x is not equal to 3 means this function we are going to use for fx. So limit x tends to 3, x square minus 9 by x minus 3 equal to f of 3. Limit x tends to 3, we can factorize it, x plus 3, x minus 3, x minus 3 equal to f of 3. Can be cancelled, so we will have limit x tends to 3, x plus 3 is equal to f of 3. You can see when x equal to 3, then f of 3 is equal to k. So you can write here k. Now we will put the limit thing value x equal to 3 here. So 3 plus 3 is 6 equal to k. Therefore k equal to 6. So in such a way we can find the value of k. If the function fx is given by this is continuous at x equal to 1, find the values of a and b. We will proceed in the same way that we have done in the previous question, but you can see here that we have to find two values a and b. As we have to find two values, so it will be better for us if we write both left hand limit and the right hand limit. Okay, so we will write in such a way, since fx is continuous at x equal to 1, therefore limit x tends to 1 minus fx, that means left hand limit, x tends to 1 plus fx, that means right hand limit, equal to value of the function at 1, f1, implies limit x tends to 1, here 1 minus means less than 1, so less than 1 means this is less than 1, x less than 1, so we have to apply this function 5ax minus 2b is equal to limit x tends to 1 plus more than 1 means this one, so 3ax plus b, and 1 equal to 1 means 11, so we will write 11. We will put x equal to 1 is equal to 11. Now we can write 5a minus 2b is equal to 11 and 3a plus b is equal to 11. Now we have to solve these two. A minus 2b is equal to 11 and 3a plus b is equal to 11. Okay, we can multiply it by 2. It will be 6a plus 2b is equal to 22, and this we can keep as it is, equal to 11. Then we will add these two. If we add these two, suppose this is number 1, number 2, we will add these two, we will get 5 plus 6, 11a, these two will be cancelled, it will be 33, therefore a is equal to 3. Now if we put a equal to 3 in any of the equation, either 1 or 2, then we will get what? Okay, therefore a is equal to 3, b equal to 2.